Welcome to my talk using Vcpkg in Anger. And we will talk about Vcpkg, obviously from the name. So you might ask why you should listen to me talk about Vcpkg. And the answer is that I started moving PackSys C++ projects to Vcpkg 3 years ago, and we use Vcpkg in various complex scenarios. For example, we have multiple interdependent packages, we have private packages, private Vcpkg remotes, we have custom target triplets, and we target a bunch of platforms. We target x64, ARMs, we target Linux, MacOS, Windows, and we actually tried some other platforms, but we currently don't have customers on those platforms, so we don't maintain them. Anyway, about this talk. So what this talk isn't. So this talk isn't a tutorial for using Vcpkg. Okay? You don't need to understand Vcpkg to understand this talk, thankfully. But if you start using Vcpkg, you might want to revisit this talk to refresh yourself. This is an advocacy for Conan. I actually think Conan is fine, but I like Vcpkg better, even although I will show you some pretty scary stuff. This implies it's not advocacy against Vcpkg, and it very definitely is not advocacy against package management in general. Use package managers. No, fetch content is not a package management. Okay? So what this talk is? It's me sharing my experience from using Vcpkg for 3 years in production, in multiple teams, and for stuff that we actually compile and then push to our customers. It will be a more realistic look at using Vcpkg. In the abstract, I mentioned that I'm tired of talks that are like, there is Vcpkg, you can depend on FMT and it will build it for you. This is what it looks like when you spend 3 years using Vcpkg and pushing it to the limit. And of course, it's me venting. A lot of the stuff is really annoying, and sometimes you need to vent. So, first, before we see some scary stuff, tips if you use Vcpkg. If you have to pick between manifest mode and classic mode, manifest mode. No questions, use manifest mode. Classic mode is stateful. It's old Vcpkg back when it was meant to be apt replacement. So if you want to install new dependency, you have to do it manually. Remove all dependency you no longer use, do it manually. Update, the same, and so on and so on. Nobody has time for that. Now next, always have version baseline in your Vcpkg specification. Why? Actually, so let's take a look at a very simple project. See how simple it is to use Vcpkg. We have 2 files, cmakelist, vcpkg.json. Cmakelist is minimal, just required version and project, and 1 dependency in Vcpkg. This is minimum by the buildable project. Let's build it. It will give us FMT in version 10, this is fine. We can start development. Great, awesome. So what's the issue? The issue is when we come back a year later. We build the project again, it starts building, and wait, we have FMT 11. Because now we are building against completely different versions of our dependencies, because we didn't specify versions. The versions that we use are just the ones that were checked out in Vcpkg at the time of last build. So I hope new major versions of your dependencies don't break you. Of course they will. I mean, I had someone complain that Catch 2 became suddenly incompatible in new version because he did this, and he got updated from version v2 to v3, which is completely incompatible with anything. So always specify version baseline. Now, there are actually, if you read the docs, if you just type into Google Vcpkg baseline, there is a good chance you will find built-in baseline. Okay, this is in the docs. It got better, but it's still the first thing I found on Google yesterday. Don't use built-in baseline. No, it's terrible. I will show you why. This is the commit from Friday, literally last commit on Friday. This is the hash. This is the same hash. We base as a built-in baseline, and we build, and we get a bunch of errors. So what's happening is that built-in baseline again operates on the Vcpkg checkout that you have on your drive. So because you didn't have checkout from Friday afternoon, maybe you just had checkout from Friday morning, you can't build. No, don't do this. So what you should be using is Vcpkg configuration, where you just say, actually, for baseline, go to Git. Go to this address, check it out, and use it as a registry. You can also put it into your main manifest file. This is good for short examples, but I don't do this. Why? Because in actual practice, you will have like 4 of these. You will have the default, you might have some private registries and so on. And that's actually a lot of space. And you will have many more of these. You will have many more dependencies. You will have to scroll to see all of them. So having it all in single file is messy, annoying. It's better to keep them split. And the last thing, remember that Vcpkg uses minimal version selection. If you are not familiar with this, this was, I guess you could say, invented for Go. And what it does is that it picks the lowest version that satisfies all constraints of the version selection, set. And this will become relevant later. We will see why. Now, the last of this prelude. So I will be using either one or two projects for the examples. It will be named very originally libfoo and foo SDK. Foo SDK will always rely on libfoo, just because this is how it works in my company, and I found all of these at work. And the manifest will contain this fictional baseline key to make it reproducible from slides. But obviously this doesn't exist. It's a shorthand for the Vcpkg configuration with the baseline at dead hash. Good? Are we all good with this? So let's talk about the first issue that you will run into when you use Vcpkg. I have sorted them by the likelihood of you having this problem. Now, the fun part is that the baseline that you specify always inserts the constraints into the resolution. What does this mean? Well, let's have libfoo again. We will say that we depend on FMT, but in some specific version that we care about. 9.10 is a good version. Why not? And we have a baseline. What happens when we build it? We get FMT 10.1.1. Why? Why do we get different version than we rely on? Because baseline has this constraint. So when baseline says 10.1 or greater, and we say 9.1 or greater, 10.1.1 wins. There is nothing really surprising about this, except for the part where you don't expect the baseline to add constraints. Now, what can you do about this? What do you do if you actually want these versions to matter? Well, you can use old baseline. You can just say, whatever, my baseline is 2 years in the past. That's so long ago that it can't overwrite my new versions at all. Okay, that's weird. Anyway, so when you use old baseline, we have an issue that you now use old versions of your transitive dependencies. And what this means is that if we go back here, we actually had these two packages, Vcpkg CMake. These are Vcpkg's helpers to build CMake-based projects. Okay? And the versions we get there are dependent on the baseline because we don't depend on them directly. And this is fine, like for a Vcpkg CMake whatever helper, the fact that you use old baseline is whatever, doesn't matter. It's unlikely to break you. What if you rely on OpenSSL? You don't want to use OpenSSL that's 2 years old. That's going to be terrible. So the other option is to use overrides. They look like this. You say, actually, I want FMT at this version. No further constraint resolution, give me FMT 9.1.0. And it works. You now get FMT 9.1.0, and you are happy. Of course, only for a few moments, because then you find out that this doesn't propagate from dependencies. So you have your SDK project. It depends on your library. You build it, and you are back to FMT 10.1.1. So what do you do about this? Well, the best thing is to hope that you don't care about the version, but if there is override, you probably cared. So you actually just say, I don't depend on FMT, but I want to override the version to 9.1.0. And that works, but it's annoying. You don't depend on this. You shouldn't have to know this exists, but you have to override it for your build to work. And this breaks the abstraction of dependency management, because you can no longer just say, give me these dependencies. You can be like, okay, so my transitive dependency needs this version, and I have to override them myself. And so you find yourself specifying versions of dependencies you have never used. And if you ever publish your project as a Vcpkg package, the same thing happens to your users. Of course, this has happened to us at work, exactly with FMT, because FMT10 had a bug where it couldn't build our library, because it couldn't format some reference tuples. And our SDK team used the library, used newer baseline, their build broke, we had to fix it, and so on. But wait, there is more. There is always more. So your old baseline, and again, we are talking about literally the baseline from Friday morning versus the baseline from Friday afternoon, might not have port in the registry. The port might be too new for your baseline. And this will cause a fail of the version resolution. Let's take a look. We see in Vcpkg versions boost CMake that there is this version, 185.0. Okay, it's there, it's present. So we will depend on it. We say, yes, we want boost CMake in this version. This should work. There is no reason for this not to work, but we have some baseline. And when we build it, we get error because the baseline is too old for that specific port. Like, as far as it's concerned, it doesn't even know that boost CMake exists. So it can't give you a version constraint. So build error. Yeah, Vcpkg is like this a lot. But that's still a good one. You know, at least your build fails early. It will be getting worse as we go on. Now, Vcpkg only supports one type of constraints on version. It's greater or equal. This is because it uses minimal version selection, and minimal version selection algorithm only supports these constraints. That's easy. Now, these constraints should never be in conflict. You should never be able to create an empty set with this constraint, because you can't overlap two of these constraints in a way that they remove all space between them. There will always be some version that exists that fulfills this. Of course, that's not true in Vcpkg world. If you resolve two constraints like this, it can fail. Let's take a look at an example. So we have our library. We use Upsail in version 2021 something. We don't care about the rest. And we have our SDK, which uses the library, and also wants to use Upsail, but in version 2023. It's a bit newer. So the reasonable expectation is that we will get this version, right? Who agrees with this expectation? Now, of course, the issue is that if this was true, I wouldn't be showing it to you, right? So let's build it, and we get an error. What does the error say? So there is a version conflict on Upsail, okay? We get 2021 from libfoo, good. 2023, and they can't be compared because they have scheme relax and scheme string. What the hell is going on? So what's going on is that Vcpkg has 4 different version types. Version or relaxed version, which is just an n tuple of digits separated by dots. Semantic version, which is the same, except it's supposed to be semantically versioned. No, there is no checking. Version date, that's your date-like string, you know, 2024-08-04. And version string, this is your release named Apple and Orange. And when you ask Vcpkg to resolve versions, it only compares versions in the same domain. And of course, strings are incomparable because you can't compare apples and oranges. That's just not how it works. But it's not as bad as it sounds, because back in the 2022, actually convinced Billy that version relaxed and somewhere should be comparable. This is like surprisingly small change, but really useful, because it fixed a lot of issues where some ports were going between relaxed version and somewhere version, relaxed version and somewhere version, and you had these islands that couldn't be compared between each other. No, you can't actually have date-like version. The Vcpkg doesn't accept this, will not accept this. I keep having arguments about this about once a year, and no, this is not happening, but it would be nice. But once again, there is something more. Now, again, remember, baseline constraints are always inserted. So what happens when you have just one library that depends on Upsail and has a baseline? Well, it's going to fail, of course, because our library uses date string as the version, and the baseline uses relaxed version because the versioning has changed. And of course, now we can't build. You know, we have just one package and it conflicts with itself when resolving the dependencies. Yeah, Vcpkg. It's a thing. Now, but these were actually like good. We will get into much worse issues now, because until now we got build failure, and and when your build fails, that's good. You caught the error early. What if we get into runtime issues? Let's get into runtime issues. So we have a library, we have some baseline, and we depend on boost circular buffer in version 180. Good. Let's build this. And we get like 40 dependencies because Vcpkg does modular boost. That's nice. But if you, there is an issue here. Who sees it? And that's actually like the reduced output. If you just build it in your console, it just scrolls past us, you get 40 more lines. What's the issue? Exactly. We are building the circular buffer at 180, which we ask for, and the rest of boost at 179. And then we link it together and we hope for the best. This is, of course, extremely IFNDR, and anything that happens to you is fair play. And Boost, of course, does not promise you to be link compatible between versions. It doesn't even promise to be API compatible between versions. Yeah, anyway, the reason I use Boost in this section is that I actually found this when updating our Boost dependencies. And I got it kind of fixed for Boost 180. #1 here means that it's like the second iteration of the recipe for this version of Boost. And to be clear, I don't want to take too much credit. I got it fixed. I mean, I found some person who knows how to fix it, and I made noise at him until he did it, okay? Now, the issue is this fixes it for a trivial case. Now, if you have this and say 181, this will be fine. But it's not fine when you actually do more work with Boost. And because the way it's fixed is that Boost packages now use version constraints when they depend on other Boost packages. So Boost 181 circular buffer says, I need these dependencies in 181 as well. But it's easy to break, and I will show you how. We are back again with our library. This time we depend on Boost ICL, and it's in version 182. Then we take our SDK, depend on library, and we say, actually, we still need circular buffer 181. Remember, 181 is more than 180, so this should be fixed now. Now, here is what will actually happen. We start building, it looks fine, except it's not. So what's happening? What's happening is that we have these two dependency trees. One from the circular buffer, one from Boost ICL, and the Boost ICL depends on its own tree with higher version, so it wins. But anything that's not in the Boost ICL dependency tree, like the circular buffer, that gets the old version. Yeah, we are back here again. And this is not the only package where this applies. Actually, if you have like split packages of any monolithic project, like Qt, KDE, there might be others, I didn't check exhaustively, then you are in this issue once again. Now, there's an interesting part in Vcpkg docs where they actually mention this issue, and they have a suggested workaround. It's a fun one. I actually really like it. I'm not kidding. So what you can do is that you can have more registries, and you can say this registry only catches these packages. So you say, actually, for Boost packages, and anything else that fits this pattern, use this baseline instead. And in theory, by specifying new enough baseline for your Boost, you can force all of them to have the same version. Now, what's the issue with this? How do we break it again? So the answer is, we just depend on your Boost version that is in the baseline. It will break instantly once again. And of course, there's another fun fact. If you take this as in documentation and you just say, I want your baseline, it won't build because there is new Boost-related package that doesn't fit into the pattern. But that's fine. You spend 1 minute looking at the error, and then you just say, OK, add this pattern to the packages from the specific baseline. Now, this is getting to even more fun stuff. So Vcpkg has this misfeature. Okay, technically it's feature, but no, it's misfeature. And it's called default features. And this is back from the days when Vcpkg was an apt replacement, when you called Vcpkg, install this package and other package, and then you told your build to actually look into this directory for its dependencies. And it's a set of features, of ports, that you build without asking. Okay, in Vcpkg, ports have features, which is like, I want my OpenCV to be able to read PNG files. So PNG is a feature of OpenCV. Now, default features will give you big packages. This is the one I run into first. So OpenCV, we want to open PNG packages, nothing more, and we no idea what this. Why are we building Cairo graphics? Font config, free type, gobject, x11, and everything else if we want OpenCV that can open a PNG file. Because it's in the default features. For some reason, all of this is in the default features of OpenCV. Now, thankfully, you can actually just disable these. You can say default features, false. I don't want default features. They are a stupid idea. And then if you build it, it looks reasonable. You know, 6 packages, zlib, Vcpkg helpers, libpng, OpenCV, PNG. Yeah, this is reasonable. This is fine. So will it remain fine? Well, of course not. Because Vcpkg will ignore you saying, I don't want default features. How does it happen? Well, let's look. We have library foo, and it doesn't want default features of OpenCV. And we have SDK. And SDK doesn't know anything about OpenCV. It just knows that it needs to use our library. Let's build it. And we are back to 45 packages. The one extra package is from libfoo. Yeah, again, we are building Cairo, config, free type, gobject. No. No, this is terrible. But it is what it is. And what's happening is that just Vcpkg completely ignores, by design, default features in transitive dependencies. Okay, if like a transitive if you have dependency that says OpenCV, no default features, only PNG, then what you actually get is OpenCV, PNG, and default features, yes, for reasons. And the reasons are, again, legacy from many years ago when it was an apt replacement. Now, this is open source, we can fix it, right? Yeah, someone tried, and it has been open for 2.5 years. And I will let you guess how long it has been since there was like last reply to the PR or something. You can guess, you know? Yeah, no, it's not moving forward for some reason. Again, there is a workaround, of course, and the workaround is exactly what you expect. You will say, actually, I depend on OpenCV. I don't know what version I depend. I don't know what features I depend, but I just know that I don't depend on default features. So, yeah, this is the workaround. It works. But of course, you can't put this into the override. So you can't just say, if it's an override, this is like forced dependency versus this is actual dependency. So how do you tell it's a real dependency? Well, you add a comment, not a real dependency. Yes, I know about the typo. When I was proofreading, I decided to keep it because it kind of fits the situation. But of course, there is more. Why wouldn't there be more? So, you know, building too much is not such an issue. You know, okay, like, I don't want my CI machines to spend 50 minutes building instead of 20 minutes building, but I can live with this, you know? And when I have the final library, I do strip it for unused code with linker and so on, so, you know, it's not so terrible. But it can get worse. Who here knows FFmpeg library? Okay, it's really cool library. It can read basically any audio, video input. I'm not going to say we like it. We use it, okay? If you ever use the C API, it's terrible, but we use it. It's nice. And the interesting part about FFmpeg is that it can be licensed under like 5 different licenses based on which subset of it you build. And the subset we use is LGPL because we are distributing a commercial product. So we just, use LGPL subset, distribute it as a dynamic library. But FFmpeg's default build, back in the day, was GPL licensed. So, when we went and used FFmpeg in LGPL configuration, and then the SDK team went and used our package, then they got FFmpeg license with GPL. Yeah, look, it has been 2.5 years. I am still extremely mad about this. Like, that's not reasonable in any way. Well, let's move on. So, at the start, we have seen that Vcpkg also gets us some helper packages. We got like Vcpkg CMake helper at version 2023 dash something. I don't know the rest of the date. But some of the helpers are unversioned. And this is fun, because what does it mean? It means that when you check out Vcpkg locally, that's where you get these helpers from. So even if you keep the same Vcpkg binary, the same baseline, the same version specs in your manifest, if you have like git pulled in your Vcpkg checkout, the build can change. And yes, I had to debug this, of course. And our CI just started failing one day. So after a few days, I found out that we periodically updated Vcpkg checkout. We did keep the old binary and the versions and so on, but the new checkout actually didn't work. It had a bug. And so I lost a few days fixing this before I figured out that I just need to roll back Vcpkg to known good version. Moral of the story, don't let your CI machines update Vcpkg implicitly. Don't let your developers update Vcpkg implicitly. And this has led me to an idea. Maybe I was wrong when I told you that you should always use baselines and versions. Maybe you should just check out Vcpkg, never change the version, and that's your like versioning scheme. Right? No, that's a terrible idea. Don't do that, okay? Because you still get actually like more power from being able to specify your versions than just checking out the Vcpkg repo at specific hash. But keep in mind that you can't move your Vcpkg checkout or things will break. I actually did find a fun example literally yesterday. So what I do is that I checked out specific version. I checked it out for completely different reasons. I needed it to reproduce one issue I have shown you earlier. And then I went to one of the builds. This one specifically, all of these examples I will show you I will show you an address where you can get them. I said build, and then I got a really weird error. In manifest mode, Vcpkg install does not support individual package arguments. I am not even running Vcpkg myself. It's all the responsibility of the Vcpkg scripts. And then it starts printing more errors, and then a whole like help message from the Vcpkg tool, and so on. What happened? Well, the scripts that are supposed to help you build, like use Vcpkg, for example, this one that helps you integrate with CMake, changed. And the binary has also changed. And now the old scripts with the new binary don't work. Okay? Now, have I scared you enough? Who here still wants to use Vcpkg? Oh, a couple of people, good. So let's talk about the good part. Who here thinks that this is going to be empty now? It's not. Actually, I have good things to say about Vcpkg. So first of all, it's really easy to get started. You check out one repo, you bootstrap Vcpkg to get the binary, then you go to your own project and you say, actually, give me new application in this directory. And it's okay, it generates Vcpkg JSON scaffolding, it even generates properly split configuration, and you can start building. This is now like Vcpkg enabled project. And you say, actually, give me FMT. It understands how to edit its own JSON, which is like the minimum, but it works. And good. You can now start building. And you will avoid a lot of the issues that I told you about, because it did like do the right job. Now, another thing that I actually like about Vcpkg is the baseline. It's causing me a lot of grief, but the grief it's causing me is because the Vcpkg tool doesn't use it properly. Because at the end of the day, the baseline is a curated set of packages that Vcpkg has, all of them has built them together and checked that they work on all target platforms. If it's like hash in the Vcpkg repository, then you know you can build all of these things together on x64, ARM, Linux, Windows, Mac. This is good. This is very useful. They spent a lot of money to run all of the builds. Now, another thing I actually really like about Vcpkg is that it exposes the package's build system. So if your dependency uses CMake to build itself and exports CMake targets, then you will get those CMake targets to use yourself. This is really valuable because it means that when you go to documentation of your dependency, for example, catch, and you say, oh, like this integration with CMake is good, I want to use it, you know that it's there. You don't have, like, if you work with Conan recreates all of the targets, and you have to rely on the fact that, like, whoever made the Conan package did not change those targets, didn't rename them, didn't make them behave differently, and so on. I have had a lot of bugs in Catch 2 about this, and Vcpkg just says, no, like this library uses this build system, you get to use it as well. Okay, now another thing I like, the triplet files. Triplet file lets you customize the build of all of your dependencies pretty easily. This is like the minimum. Triplet file, I think this isn't actually even a custom for Linux yet, but you have to say architecture you are building for, CRT linkage, and system name to get started. And then you can get started. You know, like, who here links everything statically? Yeah, okay, I should actually like drop my hand because we use FFmpeg, but everything else, yeah, just build it statically, link it, it's good. Nobody has time for dynamic linking, except when you have to deal with FFmpeg. So what do? Actually, if it's FFmpeg, it's dynamic, otherwise static. Good enough, done, and everything works. Now, similar question. Who here just builds everything with the default Linux targets where like the compiler doesn't even generate pop count because it's scared that you will run it on a machine that's older than me and it doesn't have pop count? Right? Nobody, because nobody has time for this. So we just say, okay, actually, you know, target at least N3, that's the machine that we are using in production. Or, you know, you can use whatever machine you are fine with targeting here. It's just compiler flags, and you can have them here in the triplet file, and you will get them to the dependency. Now, same question. If you make dynamic library, do you properly control the symbol visibility of your dependencies? Because if you don't know, if you build statically a library and you link it into a dynamic library, you will still expose all of its symbols. Well, we do, because we build dynamic libraries, and it's simply with triplets, you know? And who here uses sanitizers? We do, a lot, like sanitizers. But we had an issue. A lot of the sanitizers need you to rebuild everything, or they will give you false positive. For example, container sanitizer is completely awesome feature, but for it to work, everything that touches your std vector or similar container has to be compiled with the sanitizer enabled. If not, you will get errors. So you just put this into the triplet. You say f sanitize, and I don't remember the flag from on top of my head, but you can do this. It's easy. It actually is how we do it, because that's the only way not to go insane. You want to keep consistent language standards everywhere? You should. Once again, don't link together libraries that have been compiled with different language standards. Bad mojo might work, might not work. It's better to just compile everything with C++20 or whatever you use. Now, who here has ever tried to just take LTO of all of your dependencies, compile it together, and see what happens? Well, one person actually did this. It took like a day and a half. we have a lot of dependencies. But you can just do LTO in your triplet file for all of your dependencies, and then when you link it, you have LTO information for all of your dependencies. Don't do this with big projects. Or use thin LTO. And basically, any other customization that you can think of that goes through the compiler, it's easy to do. Now, this is my one dig against Conan in my talk, okay? Vcpkg does not have executable package metadata. If you have ever used Conan, then you know that if you ask Conan, hey, what are the dependencies of this package? It starts by running Python, and it runs Python script from that the dependency provides to find this out. No. No. Vcpkg does not have executable metadata. It's all just JSON. You can parse it with whatever you want, so you can write your own tools instead of running some weird Python scripts. And finally, licensing. Who here likes licensing? I hate licensing, but I have to comply with licenses, You have to do it. So who knows the licenses of all of their dependencies? Yeah, we do. We have to do it, right? And do you automatically audit them? Do you comply with MIT licenses? Like, do you generate all the notices for MIT and Apache? By the way, I hate the fact that the Apache license says that you should use like a different text for the acknowledgement than is the license text. MIT is much nicer about this. Now, Vcpkg makes this reasonably hard. Okay, it's not easy. It's never easy because you will just run into packages that are like, everybody can use it unless you use it for evil. How does that work? But what you do is that Vcpkg just gives you all of the port license files into build tree. If you have dependency, it doesn't matter how deep, you will get the license file in there, so you can just automatically scan it. It also tries to give you SPDX compliant summary of your dependencies. This is experimental stage, so you are not supposed to rely on it. But when I was building automation for our license handling, for our SDK that we distribute, I think I was like 90% happy with this. And for the remaining few libraries, I just had to go through the license files, and then I finally had to special case one or two which were just weird about their licenses. Okay, now conclusion. Don't be actually scared of Vcpkg. Okay, I have shown you some nasty examples of issues you can run into, but I did spend 3 years collecting them, pushing things kind of to the limit. But be careful when using it. Okay, I have shown you some of the edge cases you can run into. I have zero doubts that there are more that you can run into. So, kind of what you should take away is that Vcpkg is functional. It has its vars, but it's functional. And some of those vars will cause you issues. And the best thing you can do is to know about them. But it also gets things right. And it has served us well. Like 3 years into the, let's call it experiment, I would keep Vcpkg. Mostly because I don't want to invest all of this work into getting Conan, and then finding out that Conan has the same issues. I actually talked with, if you have Conan set up, keep it. I have friends who use Conan, and it turns out that when we talk together that a lot of the issues are actually very similar. I know that, for example, the CCI, the Conan Central Conan Index or something, it avoids the boost issue, but do you know how? It just says you build all of boost every time. Goodbye. Which is a solution. It works, but But if you are not using package manager, try Vcpkg or Conan. And again, no, fetch content is not a package manager. Okay? It's not. And that's the end. I'm happy to hear questions, and this is a link to GitHub repository where you can find all of the examples that you can just compile, test them, and play around with them. Okay, that's it. Questions? Yes.
I know that it kind of violates English consistency principles, but have you ever tried to supply a toolchain via Vcpkg? Because there is an experimental ability to do binary artifacts and stuff. So, and have you
If you have ever tried the experimental support for like artifacts in Vcpkg, no. I know that it's there. It's getting a lot of work actually, but basically we don't care that much for the toolchains and stuff because we use a lot of them. And what we actually might use in the close future is the caching of artifacts in the manner of like when you are getting some archive from some URL to build a package to ensure that it's mirrored in our own like infrastructure, so that we don't have issues with like random. We don't have issues when random repositories have issues as well, because that has been actually like pretty annoying from the approach that Vcpkg uses to build from sources unless you have like a valid cache. It's when your CI just fails because some repository, say the video LAN repository, had like 5-minute break where it didn't work because we use AVID dependency from there. And we can't get it for 5 minutes, now the build fails and you have to go and start the build again. And it kinda sucks. Okay, more questions? It seems like the answer is no, so I think we are done here. Thank you.